Welcome to Astronomy Daily, your cosmic connection to the stars and beyond. I'm Anna, and today we're exploring a universe of fascinating developments in space exploration and astronomy. Coming up in the next few minutes, we'll dive into the latest on SpaceX's Starship program as the FAA closes one investigation while keeping another open. We'll also get the details on Blue Origin's completed investigation into their New Glenn rocket's failed landing attempt and what it means for their upcoming launch. Then we'll marvel at the first images from NASA's groundbreaking SphereX mission, a new observatory that's set to map the entire celestial sky. Plus, we'll join the historic FRAM-2 mission that just sent the first humans to orbit Earth's poles and catch up with the NASA astronauts who finally returned home after their extended stay in space due to Boeing's Starliner issues. So strap in for liftoff as we journey through today's biggest space headlines right here on Astronomy Daily. Let's kick things off with updates from a couple of FAA investigations. The Federal Aviation Administration has recently closed its investigation into SpaceX's 7th Starship test flight, which ended in an explosion back in January. However, the agency is keeping its probe open regarding the subsequent March test flight that also resulted in an explosion during a similar phase of flight. This represents an interesting development in Elon Musk's flagship space program. According to the FAA's findings, the January flight failure was likely caused by stronger than anticipated vibrations during flight, which led to increased stress on the propulsion system hardware and its eventual failure. Despite this setback, SpaceX implemented 11 corrective actions that satisfied the FAA enough to allow the company to proceed with its 8th test flight in March. The situation illustrates the challenging nature of developing next-generation space technology. Starship, standing at an impressive 400 feet tall, is at the center of Musk's ambitious goal to eventually colonize Mars. These back-to-back explosions represent novel setbacks for SpaceX at a time when Musk has been publicly pushing for faster progress. What's particularly noteworthy is that the FAA allowed SpaceX to launch the 8th test flight while the investigation into the previous failure was still underway, a sign of the agency's confidence in SpaceX's corrective measures. However, when that flight also ended in failure at around the same phase, it raised new questions about the underlying issues with the vehicle. The FAA has made it clear that Starship cannot return to flight until the agency deems it safe enough for the public. With the investigation into the March explosion still ongoing, SpaceX faces uncertainty about when they'll be able to attempt a 9th test flight. These developmental challenges are not uncommon in the space industry, but they do highlight the complexity of creating a fully reusable super heavy lift launch system. Despite these setbacks, SpaceX continues to make incremental progress with each test flight, gathering valuable data even from failures. For now, the space community watches with anticipation as SpaceX works to identify and address the root causes of these failures, with the hope that future tests will bring Starship closer to operational status. Meanwhile, in another decision from the FAA this week, Blue Origin has reached a significant milestone in its New Glenn program, with the Federal Aviation Administration announcing on March 31st that it has accepted the findings of Blue Origin's investigation into the failed booster landing during the rocket's inaugural flight on January 16th. While the first New Glenn mission successfully delivered its upper stage to orbit as planned, the first stage booster was unable to land on Blue Origin's recovery ship in the Atlantic Ocean. According to the FAA's statement, the mishap report identified the proximate cause as the booster's inability to restart its engines, which prevented the critical re-entry burn from occurring, resulting in the loss of the stage. Dave Limp, Blue Origin's chief executive, had previously hinted at the problem during the Commercial Space Conference in February, suggesting that issues with propellant management were behind the failed landing attempt. Now, the company has officially confirmed that the 3 BE-4 engines did not reignite properly, leading to the landing failure. As part of the investigation, Blue Origin has identified 7 corrective actions that will need to be implemented before the next launch. These measures primarily focus on propellant management and engine bleed control improvements. The company has stated they're already addressing these issues in preparation for their next flight. With the investigation complete and the FAA's acceptance of the findings, Blue Origin is now authorized to return to flight, provided all other licensing requirements are met. The company has set an ambitious timeline, targeting late spring for the next New Glenn launch. This upcoming mission will include another booster landing attempt, which they've playfully nicknamed "So You're Telling Me There's a Chance." In a social media post, LIMP expressed confidence in their approach, stating, "We're confident that the propellant and bleed control work we're doing will increase our chances of landing the booster on our next flight. And like we've said all along, we'll keep trying until we do." While Blue Origin hasn't provided specific details about potential payloads for the next mission or a more precise launch date, the completion of this investigation represents a critical step forward for the company's heavy-lift rocket program. The recovery of the first stage is a key part of Blue Origin's strategy to make New Glenn partially reusable, following a similar approach to that pioneered by SpaceX with its Falcon 9 rockets. Next up, NASA has reached an exciting milestone with its newest space observatory. The SphereX mission, which stands for Spectrophotometer for the History of the Universe, Epoch of Reionization and ICE's Explorer, has powered on its detectors for the first time since launching on March 11th, capturing its inaugural images from space. These initial images, while still uncalibrated and not yet ready for scientific use, confirm that all systems are functioning exactly as intended. Each SphereX exposure consists of 6 images that together provide a remarkably wide view of the cosmos, with each image containing more than 100,000 light sources, including stars and galaxies. The observatory's field of view covers a rectangular area approximately 20 times wider than the full moon. What makes SphereX unique is its approach to surveying the sky. Unlike telescopes such as Hubble or James Webb that focus on small, detailed areas, SphereX takes a much broader perspective. The observatory detects infrared light, which is invisible to the human eye, and breaks it down into remarkable detail. Each of SphereX's 6 detectors captures light in 17 distinct wavelength bands, allowing scientists to analyze a total of 102 different infrared hues in every exposure. This spectroscopic capability is crucial for understanding the composition of celestial objects and determining their distances. By collecting light from hundreds of millions of stars and galaxies across more wavelengths than any previous all-sky survey telescope, SphereX will help scientists investigate fundamental questions ranging from the physics that govern the universe less than a second after the Big Bang to the origins of water in our galaxy. The observatory works through an ingenious system. When light enters SphereX's telescope, it's directed down 2 separate paths that each lead to a row of 3 detectors. These detectors function like eyes, and sitting on top of them are specialized color filters. Unlike standard filters that block all wavelengths except one, SphereX's filters are more like rainbow-tinted glasses, with the blocked wavelengths changing gradually from the top of the filter to the bottom. During its 2-year primary mission, SphereX will map the entire celestial sky 4 times over. Once routine science operations begin in late April, the observatory will take approximately 600 exposures every day. For the spacecraft to properly detect infrared light, its detectors and other hardware have been cooling down to their final operating temperature of around minus 350 degrees Fahrenheit, as heat can overwhelm the telescope's infrared detection capabilities. Project scientists are clearly thrilled with the results so far. As Olivier Doré, SphereX project scientist at Caltech and NASA's Jet Propulsion Laboratory, remarked, "Our spacecraft has opened its eyes on the universe. It's performing just as it was designed to." This sentiment was echoed by Jamie Bach, SphereX's principal investigator, who noted that, based on the images we are seeing, we can now say that the instrument team nailed it. Next, an update on the story we brought you yesterday. In a historic first for human spaceflight, SpaceX has successfully launched the Fram-2 mission, sending 4 people into a polar orbit around Earth, a trajectory never before flown by humans. The Crew Dragon spacecraft Resilience lifted off on Monday at 9:46 p.m. Eastern Time, carrying a crew of private astronauts who are now experiencing views of our planet that no human has ever witnessed firsthand. The mission is commanded by Chun Wang of Malta, who personally funded this groundbreaking venture. Wang is joined by an international team, including Norwegian Jannicke Mikkelsen serving as vehicle commander, German pilot Rabea Roeg, and Australian Eric Phillips as mission specialist and medical officer. All 4 are spaceflight rookies, making their achievement even more remarkable. Today, we become the 681st humans to fly above the Kármán line and the 626th to orbit the Earth, Wang announced shortly after reaching orbit. The crew is now sending back breathtaking images of Earth's most remote regions, including unprecedented views of the polar regions captured through Resilience's cupola window. The mission derives its name from a famous Norwegian exploration vessel that conducted pioneering Arctic and Antarctic expeditions in the early 20th century. Living up to its namesake, Fram 2 aims to push boundaries with nearly 24 scientific experiments during their orbital journey. The awe-inspiring images being shared by the crew showcase Earth's poles blanketed in white, offering a perspective that brings home the fragility and beauty of our planet in a way never before documented by human eyes. These unique orbital observations may provide valuable scientific insights while also capturing the imagination of people worldwide. It seems the world's media have suddenly discovered spaceflight, and so they can't get enough of Butch and Suni. And yes, even we have another update today. After 9 months in space, NASA astronauts Butch Wilmore and Suni Williams are finally readjusting to life on Earth, following their unexpectedly extended stay aboard the International Space Station. What was originally planned as an 8-day test mission aboard Boeing's Starliner spacecraft turned into a 9-month orbital marathon after propulsion system issues forced NASA to bring the capsule back empty. "It's great getting back. I went for a run, although very slow," Williams shared in a recent interview from Houston. "Just felt good to feel air, even though it was humid air, like blowing past you and seeing other people on the track. It's really nice. It's home." Both astronauts, who returned to Earth aboard a SpaceX Crew Dragon capsule in March, underwent routine medical checks before reuniting with their families. Despite the extended mission, they seem to be embracing simple Earth pleasures like walking dogs and spending time with loved ones. But their work with Boeing is far from over. The veteran astronauts, both former U.S. Navy test pilots, are scheduled to meet with Boeing leadership this week to discuss Starliner's future. As the only humans to have actually flown in the spacecraft, their insights are invaluable. "We had a very unique perspective of being in the spacecraft. Nobody else had that perspective," Williams explained. She added that they'll be discussing where we stand and where we think we need to go with Starliner's development. NASA and Boeing now plan to conduct ground tests of Starliner's troubled propulsion system this summer, with the next flight test not expected until early 2026. That mission could well be uncrewed, a possibility Williams seems to support. "I think that is already the plan because there will be new components added to the spacecraft or replaced on the spacecraft. So we'd really like to test that out, see how that works," she said. "I think that's probably a smart, wise idea." The Starliner program has faced significant challenges, with development costs ballooning to more than $2 billion since 2016. For NASA, these setbacks have left SpaceX's Crew Dragon as the agency's only U.S. option for transporting astronauts to and from the ISS, a concerning situation given NASA's desire for redundant access systems. Despite these challenges, Wilmore and Williams maintain their professionalism and commitment to helping Boeing overcome Starliner's technical issues, demonstrating the resilience that defines the astronaut corps. The commercial spaceflight landscape is experiencing both remarkable breakthroughs and significant growing pains, as evidenced by recent developments across the industry. We're witnessing a fascinating contrast between SpaceX's rapid iteration philosophy and Boeing's more traditional approach to spacecraft development. SpaceX continues to push boundaries with its Starship program, despite consecutive explosive test failures. These setbacks highlight the inherent challenges of developing revolutionary rocket systems, yet the company maintains its aggressive testing schedule. This approach, building fast, testing often, and accepting some failures, has become SpaceX's signature methodology, though it occasionally puts them at odds with regulatory bodies like the FAA. Meanwhile, Boeing's struggles with Starliner represent a different challenge in commercial spaceflight. The company's more conservative development process hasn't shielded it from significant technical issues, cost overruns, and schedule delays. The contrast between Starliner's difficulties and SpaceX's successful Crew Dragon program underscores how different engineering cultures can yield vastly different outcomes. Blue Origin's partial success with New Glenn adds another dimension to this competitive landscape. Their ability to reach orbit on the first attempt was impressive, even if the booster landing failed. This positions them as a potentially serious competitor in the heavy lift market, though they remain years behind SpaceX in operational capability. What's particularly striking is how these commercial developments are reshaping human space exploration. NASA has effectively outsourced low Earth orbit transportation, transforming from operator to customer. This transition frees the agency to focus resources on deep space exploration while leveraging commercial innovation. The emergence of purely private missions like FRAM-2 signals another evolution in commercial spaceflight, moving beyond government contracts to entirely new markets. These missions demonstrate growing commercial capabilities while expanding our understanding of what's possible in Earth orbit. Despite the challenges we're seeing, competition between multiple providers is ultimately strengthening the industry. Each failure provides valuable data, and each success expands capabilities. The current difficulties facing these companies aren't signs of failure, but rather the expected turbulence of an industry pushing into new frontiers while striving to make spaceflight more routine, reliable, and accessible. What an incredible journey through space news we've taken today. From the ongoing development challenges with SpaceX's Starship to Blue Origin's New Glenn progress, NASA's exciting new SphereX telescope capturing its first images, and the groundbreaking FRAM-2 polar orbit mission. We've also checked in with astronauts Wilmore and Williams as they readjust to Earth after their extended stay in space. These stories collectively showcase both the challenges and triumphs that define our current era of space exploration. Whether it's the regulatory hurdles facing private companies or the cutting-edge science being conducted in orbit, we're witnessing a remarkable period of innovation and discovery. This has been Anna, your host for Astronomy Daily. If you've enjoyed today's episode and want to stay updated on all the latest space and astronomy news, please visit our website at astronomydaily.io. There you can catch up on all our previous episodes, read the latest space news, and sign up for our free daily space news newsletter. You can also find us across social media. Just search for Astro Daily Pod on X, Facebook, YouTube Music, Instagram, and TikTok. Thank you for listening, and remember to keep looking up at the stars. The universe is full of wonders, and we'll be here to share them with you. Until next time.